All right, let's wrap up Unit 8. So we're going to look at intermolecular forces. There's really only three types of intermolecular forces that we're going to talk about, and this is going to be the van der Waals, the dipole-dipole, and the hydrogen bonding. And so intermolecular forces are basically just weak forces that cause an attraction between molecules. And if you look here, chlorine tends to be a more negative ion, and it is slightly attracted here to the hydrogen ion. And these are relatively weak. They're very easy to break. And it's important to know this because with covalent bonding, they tend to be just somewhat attracted to each other, but since they are weak attractions between each one, this is why we get low melting points and low boiling points, and just some of the reasons why they act the way they do. So as I said, we have the van der Waals, we've got dipole-dipole, and hydrogen bonding. And these are actually in order of the strength. So van der Waals are very weak, dipole-dipole are about in the middle, and hydrogen bonding, these are the most strong of the intermolecular forces that we will talk about. So van der Waals are the weakest. They will occur between nonpolar molecules, and they're very temporary. And basically, if you have more electrons, the greater the force. However, these are very easy to break. These will probably be some of our lowest of our melt point solids that we would deal with. From there, we move up to the dipole-dipole intermolecular forces, and these will occur between polar covalent molecules. They will have partial negative ends, and they'll be kind of slightly attracted to the partial positive end of another. So see how we have bromine and chlorine bonded together, and they arrange themselves in this really pretty cool organized fashion to where the negative and the positive are aligned to each other, the positive and the negative aligned to each other. So that has like this nice attraction. And basically, the more polar the compound is, the more this attraction grows. And that kind of makes sense. So the stronger the magnet, the stronger the hold, the stronger the attraction. Okay, from there we will move into the hydrogen bonding. These are the strongest. These will occur between a hydrogen atom and an oxygen atom, a nitrogen atom, and a fluorine. So, you know, I like my little secrets to remember things. And well, hydrogen bonding is fun. Ha ha, it's not that funny. But anyway, it should help you remember which elements will form hydrogen bonds. So you have to have a hydrogen, that's first and foremost. And then the other things you need to have is a fluorine atom, an oxygen atom, and a nitrogen atom. So, what type of intermolecular force occurs between molecules of hydrogen? Don't jump the gun and automatically say it's going to be hydrogen because we're missing one of the other elements, aren't we? So since this is just two hydrogens bonded and it'll be a linear structure and it is nonpolar, this is going to be the van der Waals because, as I said, hydrogen bonds are nonpolar. So what about what kind of attraction is between nitrogen and hydrogen? So keep in mind, this would actually be a pyramidal shape. It would be considered polar, and we do have hydrogen, so that makes me think, is this going to be hydrogen bonding? So what are the three elements that we must have? Remember, hydrogen bonding is fun, so we need to have fluorine, oxygen, or nitrogen, and we do have nitrogen, so this would be hydrogen bonding, because remember, can't forget about this. So let's check our understanding. What type of force exists between the molecules of hydrogen and fluorine? And I sure hope you said hydrogen bonding because fluorine is one of the elements that would occur with a hydrogen to form hydrogen bonding.